All right, welcome back. So this video we're going to talk about algebra, right? And we're going to specifically talk about the Finnegan's algebraic algorithm. All right, this is something that I wrote and developed in an effort to teach you how to solve algebraic equations that you will be solving this year and every year after this in high school, right? So this might be the most important video I make for you. So make sure you take good notes, make sure you rewatch this a few times, and apply what I'm teaching. Okay, so an algorithm, that's a computer science term like coding, that kind of stuff, right? An algorithm is just a word that means it's a set of instructions, right? So if you're going to write an algorithm to make a peanut butter and jelly sandwich, you would start by saying, take 2 pieces of bread, get your knife, get your peanut butter, get your jelly, open the jar of the peanut butter, so forth and so on. Really detailed instructions on how to accomplish a task, right? Computer scientists use algorithms to do simple codes, right? Video game developers, when you press A, your character jumps, right? That's an algorithm, right? Same thing in math. It's a set of instructions to complete a task. In this case, it's solving a variable, right? So a couple of key terms we have to pay attention to. A variable. What is a variable, right? A variable in math and science and computer science, it's basically a value that could change given a certain context, right? It's usually a letter. It's always a letter. Usually it's X. It stands for the unknown, right? And what we mean is X could be any number of things. That's why we call it a variable, because it could vary on its value. Yeah? Okay? A coefficient is basically a number before the variable. All right? It tells you, it basically tells you how many of that thing there are. So for instance, 3x tells us that there are 3 x's, right? And so 3x, the coefficient would be 3. The variable would be x. Okay? That's about as simple as I can make this definition to help you understand it, right? 3x, the coefficient's 3, the variable's x. The last number, or the last definition I want you to pay attention to is something called a constant. Now, if you think about constant in your normal life, you know, I'm constantly bored in math class, right? It's something that doesn't really change that often, right? So a constant is basically a value that cannot change. It's a number, all right? It's a number. 3 plus 5 equals 8. 3, 5, and 8 are all constants because 3 is always 3. 5 is always going to be 5, and so forth and so on, all right? So those are the terms you want to pay attention to as we move through this. Okay. Let's get to the actual algorithm itself, okay? Step 1. Again, I wrote this. I don't like fractions, and so if I see a fraction in my equation, I'm immediately going to attack it and get rid of it. So I'm going to cancel out the fractions, okay? Make sure there's no more fractions left in my equation, as much as I can help it. Step 2, distribute. Well, what I call double rainbow. Sometimes it's triple rainbow. But usually it's double rainbow in our world, right? We haven't gone over the distributive property probably yet, but that's going to be in another video. But that is something you want to do early on in your algorithm. So cancel out fractions, distribute. Number 3, combine like terms. Okay? Like terms, what does that mean? Well, constants are like terms and variables are like terms. You cannot combine a constant and a variable because they're not the same. They're different families, and so you cannot combine them in math. 3 plus 5 equals 8. We can combine 3 and 5 because they're both constants. X plus x equals 2x or we can combine those because they're both variables, right? So you cannot combine unlike terms. They must be like. That's what we mean by like terms, okay? Step 4. Let me get organized here. Step 4, move all the variables to the left. And when I say that, I mean left of the equal sign. Left side. That's what I mean. Step 5, move all the constants to the right. Again, of the equal sign. Maybe I'll put that. I don't want to confuse yourself. Maybe make a note in your notebook. Left of the equal sign, all the variables. Right of the equal sign, all of the constants. We use this. We use addition and subtraction to accomplish this, right? Could you have the variables on the right and the constants on the left? Absolutely. They're equivalent. Okay, so whether the x's are on the left or the right, it doesn't really matter. I'm choosing to move all mine to the left because I want to give you a groundwork, a foundation to solve these equations. If you want to come up with new strategies and move stuff around how you want, it's totally fine. But as a baseline, this is where we're at. Variables on the left, constants on the right. Step 6, isolate the variable. What does isolate mean? It means to make it alone, right? So if you get 3x equals something, you got to break that variable up in its constant, right? So if you get a variable and a coefficient, I got a typo. It's not a constant, it's a variable and its coefficient. On the fly, I'm updating my work. All right, so if you get a variable and a coefficient like 3x, you got to break up that so you're left with just x. We want to isolate the x because that's what we care about. That's what the unknown value is, right? The way we accomplish this, usually it's using multiplication and division. So when we're breaking up or when we're isolating, when we're tearing apart, we're using multiplication and division. When we're moving things around from one side to the other, we're using subtraction and addition. Once you've done that, once you've isolated, you're done. Box the solution. And then you're finished. Step 7. These are all really important. Now, is every single equation going to use every single step? No. No, right? The way algorithms work is if this was computer code, the computer would check to see if this step needed to be done, and if it didn't, then it would just skip it and move on. All right, so in the peanut butter and jelly example, let's say someone left the peanut butter jar out, and your algorithm said, take the peanut butter out. You would notice the peanut butter was already out, so you would skip that step and go on to the next one. Okay, so I wrote it out completely, but you're not going to use every step, every equation. You're going to see what's appropriate. All right, let's look at an example. We're going to start very, very simple, okay? I'm going to keep this right here, and we're going to start. We call these one-step equations because guess what? They only use one step. Let me move my head out of the way. So I'm going to keep my algorithm really close because that's my best friend, right? So our first equation is x plus 4 equals 3. Let's look at our steps. Are there any fractions? No, we move on. Is there anything to distribute? Nope, there's no parentheses, so we move on. Can I combine any like terms? Can I combine these two? No. Is there anything to combine over here? No. So there's nothing to combine, so we move on. Are all the variables on the left side? Well, are there any x's over here? Nope, so we move on. Step 5, move all constants to the right side. Are all the constants on the right side? No. I see a 4 right there. So notice with this simple equation, I skipped all 4 steps before I actually did any real work. Yeah? So step 5, move all constants to the right. And what are my tools again? Oh yeah, I can use addition and subtraction. So, one thing I did not write down in my definitions is this idea of an inverse operation. An inverse operation just means the opposite. So if I want to move this 4 over, I need to do the opposite. The opposite of addition is subtraction. Because this is an equal sign, I need to make sure I do the same thing to both sides. I need to balance it out. Okay? So I subtract 4 from both sides. That leaves me x equals 3 minus 4. Do not say positive 1. Right? This is negative 1. 3 minus 4 is -1. All right. Isolate the variable. Is the x all by itself already? Yes, it is. Box it up. Step 7, we're done. That's it. That's it. We tested the algorithm and it worked. Okay, let's look at the next one. 3x equals 15. No fractions, no distribution, nothing to combine. All the variables are already on the left side. All the constants are already on the right side. Remember, this 3 is not a constant. It is, sorry, but it's another C word, right? It's a coefficient because right now it's attached to the x. If I try to subtract 3 from both sides, that x has to come with it because they're together. So all the constants, the 15 all by itself, that's fine. Now I'm on step 6, isolate the variable. I need to break up the variable with its coefficient. I need to split this couple up. What are my tools? Multiplication and division. Remember, inverse operation. 3x is the same thing as 3 times x. This is always multiplication. You have to memorize that. 3x is the same thing as 3 times x. All right? So what's the opposite of multiplication? Of course, it's division. We don't use, you're not going to do stuff like this. That's not how algebra works. We don't use this symbol anymore. That's arithmetic. That's like lower grades, 3rd and 4th grade, right? We just use the bar, which represents a fraction, which means division, yeah? So 3x divided by 3. And again, I must do the same exact thing to both sides. 3x divided by 3, those cancel out, right? 3 over 3 is 1. 1x is the exact same thing as x. There's always an invisible 1 there. 15 divided by 3, 5. Variables isolated, box up the solution. All right, you made it. Study this, memorize this, and I promise you, you're going to crush every algebra problem that comes your way. All right.